In lesson 6, we're going to talk about factors and divisibility. You're going to identify the factors of a number. You're going to identify common factors and greatest common factors, or GCF, of two numbers. They're going to test the divisibility of numbers by 2, 3, 4, 5, 6, 8, 9, and 10 using divisibility rules. Two definitions you need to know is divisibility and greatest common factor. I've given you a vocabulary worksheet for this assignment. I have also included the rules of divisibility on that sheet, so you'll want to pull that up right now, pause, go back, get it out, print it off, and then do this video. You recall that factors are numbers multiplied to form a product. We know that 3 times 5 equals 15, so 3 and 5 are both factors of 15. Well, 1 times 15 is also 15, so 15 is also a factor of 15. So if we were to write the factors of 15, we would write 1, 3, 5, and 15, because all of them will divide into 15 evenly without a remainder. So that leads us to this definition right here that says that the factors of a number are the whole numbers that divide the number without a remainder. As you can see down here, that's illustrated. That's why those 4 numbers are all factors of 15. One goes into one. In this example, it's factors of 10 instead of 15. 1 goes into 10 10 times, 2 goes into 10 5 times, 5 goes into 10 2 times, and 10 goes into 10 1 time. So your factors of 10 would be 1, 2, 5, and 10. So let's see if you can do that with the factors of 12. Write the whole numbers that are factors of 12. You should have came up with 1, 2, 3, 4, 6, and 12. All those will divide into 12 evenly. It helps to pair them up like this so you don't miss any. But all those go into 12 evenly without any remainders. So your correct answer would be 1, 2, 3, 4, 6, and 12. List the factors of 51. This one's a little bit harder because it's a much larger number. See if you can do it on your own. If not, we'll go over it together. Okay, as we try to think of whole numbers that divide into 51, we obviously know 1 and 51, but there's also 2 other numbers that go into 51, which are 3 and 17. One of the rules for what is divisible is the rule for number 3. To know if 3 will go into a number, it says that if you add up the last 2 digits, or I believe it's the last 3 digits, we'll see, and you can divide that by 3, then it is divisible by 3. And 5 plus 1 equals 6. And can 6 be divided by 3? It can. So we know that 3 is a factor of 51. And we'll go over that in greater detail in a future slide. You'll see that. We'll go over those rules together. Plus, I'm going to have you watch a video from Khan Academy that does a really good job of teaching those also. Find the greatest common factor of 18 and 30. What it's asking you to do here is to find out what's the highest number that goes into both 18 and goes into 30. That's why they call it common factor, is because the number goes into both of these. See if you can figure out which number that is. You should have came up with the number 6. The factors of 18 are 1, 2, 3, 6, 9, and 18, and the factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. Again, you see that rule of 3 that I just showed you in the slide before. 18 equals 1 plus 8 equals 9. Can 9 be divided by 3? It can, so that's why that 3 shows up. And can 3 plus 0 equals 3? Can 3 be divided by 3? It can. So we know that 3 goes into both of these numbers immediately from that rule. That's just to tie it back in with the prior slide. Our greatest common factor, for 18 and 30 is 6. And here's the test divisibility form. Hopefully you printed this out. You can find it. Here it is for 3. The sum of the digits can be divided by 3. So you had 5 plus 1 equals 6. Remember that? So we know that 3 will go into 51. Would 3 go into, for example, would 3 go into 72? Yeah, it would, because 7 plus 2 equals 9. Does 3 go into 9? It does. So let's go through these. So 2 works if the last digit is an even number, like a 0, a 2, a 4, an 8. 4 works if the last 2 digits can be divided by 4. So if the last 2 digits were 20, can 20 be divided by 4? Yes, so you know that 4 is a factor. 8 works if the last 3 digits can be divided by 8. So 801, can that be divided by 8? It can't. So 801 is not divisible by 8. 5 works if the last digits are either a 0 or a 5. 10 works if the last digit is 0. 3 if the sum of the digits can be divided by 3. 6 if the numbers can be divided by 2 and by 3. And 9 if the sum of the digits can be divided by 9. And then numbers ending in 1, 0 are divisible by 2. If it has 2 zeros, it's divisible by 2 and 4. If it has 3 zeros, it's divisible by 2, 4, and 8. I don't expect you to memorize these, but some of them you should know intuitively and be able to know them. But watch the video from Khan Academy also. It'll help you with a lot in knowing your divisibility. Which whole numbers from 1 to 10 are divisors of 9060? So which numbers between 1 and 10 will go into 9060? I'll go ahead and help you out with I don't tell you that 2 will, because I know that 0 is an even number. See if you can get them all. This is what you should have came up with right here. Number 1 is the divisor, of course. And we find that 9060 passes the test for 2, 4, 5, and 10, but it doesn't for 8. The sum of its digits equal 15, which can be divided by 3, but not by 9. And since 9060 is divisible by both 2 and 3, we can include 6 into that, the rule for 6. So the only number from 1 to 10 we have not tried is 7. And there's no simple rule for 7. You just have to do it. And 7 doesn't work. So our answer to which whole numbers from 1 to 10 are divisors of 9060, it's 1, 2, 3, 4, 5, 6, and 10. This is your written practice. These are the numbers that you need to do and send to me tonight, please. And we'll see you tomorrow in class. We'll work on these 30 problems, get them done.